All right, so let's get right into it. Something really strange is happening deep beneath our feet. A mysterious change is creating this growing weak spot in our planet's defenses. It has a name, the South Atlantic Anomaly. And the big question we're tackling today is, is this just a temporary glitch, or is it a sign of something way bigger?
So first, let's just do a quick recap. Our planet, right? It's constantly getting blasted by charged particles from the sun, from deep space, and the only thing protecting us is our geomagnetic field. Think of it like this invisible force field, a shield, that's generated by our planet's core, and its whole job is to deflect all that dangerous cosmic radiation. But here's the thing, that shield, it's not perfect. Just look at this map. You see that massive blue patch? It's stretching all the way from South America over to Africa. And that blue means there's a huge drop in the magnetic field's intensity right there. That is the South Atlantic Anomaly, or the SAA for short. It's literally a growing dent in our planetary armor. So what does this weakness actually mean? Well, normally you've got these things called the Van Allen belts. They're basically rings of trapped superenergetic particles that sit thousands of kilometers above us, way up there. But inside the SAA, that inner belt takes a nosedive. It dips down dramatically, sometimes as low as just 200 kilometers. And that means a zone of really high radiation gets brought way closer to the Earth's surface.
And get this anomaly is on the move. It is not sitting still. We know this from satellite data, from missions like the ESA's Swarm, and they show it's actively creeping westward at about 20 kilometers every single year.
And as if that wasn't enough, it's also getting bigger. The whole area of this anomaly is expanding. We're talking about a rate of roughly 5% every couple of decades. So yeah, it's not just on the move. It's an actively growing feature of our planet's magnetic field. But maybe the weirdest, most surprising discovery lately? It's not just one single weak spot anymore. Nope. The anomaly is actually splitting in two. It's developing these two distinct centers of weakness. There's one over South America, and now a second, newer one that's intensifying pretty quickly southwest of Africa.
Okay, so what in the world is causing all this? To find the answer, we gotta take a journey. A really deep one. We're talking 3,000 kilometers straight down to the boundary between our planet's molten core and its rocky mantle.
Now, remember how our magnetic field gets made in the first place? It's a process called the geodynamo. And it's all driven by this churning, swirling ocean of liquid iron in the Earth's outer core. The best way to picture it is like a giant, planet-sized electrical generator.
Okay, so the number one suspect for the SAA is this really bizarre thing happening right at the edge of that dynamo. They're called reverse flux patches. Here's the deal. In the southern hemisphere, the magnetic field lines are supposed to flow out of the core, right? But in these weird patches, they do the exact opposite. They flow back into the core. It creates this kind of magnetic short circuit, and that causes a massive weakening of the field way up here at the surface, which we see as the SAA.
And this is really what geophysicist Professor Chris Finlay was talking about. He said there's something special happening in this region that is causing the field to weaken in a more intense way. So of course, scientists are watching this like hawks, because these changes, they give us this rare and credible window into the deepest workings of our planet.
All right, let's be honest. A growing, splitting, weak spot in our magnetic shield. That sounds pretty alarming, right? So what are the actual risks here? It's time to separate the real science from, the sci-fi stuff.
So the real risk, the one we actually have to worry about, is for our technology up in space. You see, satellites in low Earth orbit, they fly right through that part of the radiation belt that's dipped down. And when they do, it can cause what are called single event upsets, which is basically a fancy way of saying it messes with their computers, just flipping bits from a 1 to a 0. And in some cases, it can even cause permanent hardware damage. I mean, the Hubble Space Telescope, it actually has to shut down some of its most sensitive instruments every single time it passes through the SAA, just to protect them. But what about us down here? What about flying? There's this myth that keeps going around that it's dangerous to fly through this region. And the simple truth, it's just not.
And listen, this isn't just a guess. It's been measured. There was a whole research mission dedicated to this called Atlantic KISS. They flew airplanes with super-sensitive radiation detectors at 13 kilometers up. That's normal flight altitude, right through the heart of the anomaly. And their finding was crystal clear. No indication of increased radiation exposure was found. Our atmosphere, it turns out, is more than enough of a shield. So passengers, crew, you are not exposed to any extra radiation from the SAA. Period.
Okay,
so we're safe on our flights. That's good news. But that brings us to the really big one. The question everyone wants to know. Is this growing, splitting, moving anomaly a sign that Earth's entire magnetic field is getting ready to flip?
And you know what? It's a totally fair question to ask, because the magnetic field as a whole is getting weaker. If you look back over the last 2,000 years, it's lost about 30% of its strength. But the really wild part is that the decline has sped up lately. We've seen a drop of about 9% in just the last century and a half. And that steady decline is exactly why scientists are taking the whole idea of a pole reversal very seriously.
But are we actually close to a tipping point? Let's look at the hard data. The overall strength of the field is measured by something called its dipole moment. And by looking at the history locked in ancient rocks, scientists have figured out that a reversal only becomes likely when that number drops below a threshold of about 2. So where are we right now? We're at 7.7. As you can see, we are still way above that critical point. We're not even close.
So here's the bottom line. Even if the field keeps getting weaker at the faster rate we're seeing today, it would still take at least another 1,000 years, and probably a lot longer, just to get to the point where our reversal is even a real possibility.
And this really is the consensus view among the experts. Professor Finlay points out that what we're seeing is way more likely just a decade-to-century timescale fluctuation. In other words, the field has done stuff like this before. It's weakened in the past without actually flipping. So yes, we're in a period of instability, for sure. But we are not on the verge of a complete pole reversal.
So if it's not a sign of doom and gloom, then what exactly is the South Atlantic Anomaly? Well, the answer comes when we stop looking at it as some kind of scary omen for the future and start seeing it for what it is, a message from our planet's deep past. So let's just lay out the scientific verdict nice and clear. First up, a full pole reversal is not happening anytime soon. What we're seeing right now is probably something called a geomagnetic excursion, which is like a big disturbance that doesn't go all the way, or just a long-term wobble. And what's more, research shows that weird spots like the SAA have popped up in Earth's history before, and they didn't trigger a reversal then. And finally, and this is so important to remember, a true pole reversal isn't like flipping a switch. It is a slow, messy, complicated process that takes thousands of years to unfold. So in the end, the South Atlantic Anomaly isn't something to be afraid of. Instead, it's this incredible scientific opportunity. It's like a living laboratory that lets us peek into the chaotic, powerful engine at the very center of our world. It's a direct window into the Earth's core. So the real question isn't, oh no, what's it going to do to us? The real question is, what will it reveal to us next?